Hi, good afternoon. Welcome back.
Hello.
Hello. I know it's kind of a drowsy Thursday afternoon. I can kind of feel it in the room and in the air. But we're going to try to make this one as exciting as we can. We're going to do construction, so hopefully it's not too much heavy thinking at the end of the week. And then this will be our last lecture for the week. Yay, rejoice. All right, so you will need a compass and a straight edge, the super expensive straight edges. So if you don't have one yet, go ahead and gather them there in the usual space there on the supply shelf. While those few of you who need to get one, go ahead and grab one. It's all right. Okay, it's all right. You just brush it onto the floor for now and use the broom later.
Good job.
Let's just review what we've done so far. So day one. Okay, we've done all of these notes so far, all of this really wonderful work and conversations. Here we go. We've got some room for KWLs. This was our first construction moment. We're going to do another construction today. And here was this week. So this week we talked a lot about addition postulates. We did a lot of algebra stuff. We did distance in 2 dimensions, which you might have seen back in Algebra 1, so it looks familiar. Also realize that it looks good. We're going to come back to it when you do Pythagorean theorem. We looked at midpoint both on a line and in 2 dimensions, and you'll want to leave a page so that you can KWL this particular lesson. So go ahead and title a page so you know I'm going to leave that blank for my KWL Chapter 1, Lesson 2 and 3. I want you to see if we can get this done by the end of class day tomorrow. I will give you the whole work day tomorrow so that you can finish it up. Okay? We'll see where you are about 10 minutes before the bell rings tomorrow. See if I need to do an extension or not. So today's notes are going to be here on the very next page, so go ahead and start setting those up for me. The title is located, as always, right under the La Feria logo. And the objectives today are handwritten for you on the left side of the whiteboard. For some reason, my video recording program is starting to be really weird. So some of the text isn't coming out the way I want it to.
Why are you starting on this side?
Because I've got a KWL on this side. Yeah, if there's not enough room, you don't have to be on the exact same side of the page as I am all the time, okay? You don't even need to turn the page when I do. Just keep going, and when you run out of room, go on to the next page. I think your notebook is bigger than mine, so you're probably going to turn the page less often. All right, today's lesson code is going to be Chapter 1, Lessons 2 and 3, and we're titling it Construction of a Perpendicular Bisector. Focusing on spelling that word right. And today is the 17th of September. Construction of a perpendicular bisector. Give you guys just a few moments to get title and objective down, and then we'll get started with our first vocabulary words for the day. Get out paper and still take notes, and you can add it in later. All right, our first vocabulary word for the day is going to be the word perpendicular. You heard that word before?
Mm-hmm.
Yeah, what's it mean? You don't know the exact definition, okay. What do you remember about the word? It's like a plus. You guys, and then a lot of you are making the hand motions. It looks like a plus. All right. Can you give me more than just it's a plus?
Intersecting.
Intersects. We got some intersecting lines going on. Fantastic. Anything?
90 degrees.
And 90 degrees. I was just about to ask if there was anything special about that intersection. And then we got 90 degrees. But in this class, I want to take these very specific definitions you've been given and try to broaden them and make them more general so that they can be used in other places and with other objects. So we're going to say perpendicular happens when there's an intersection at 90 degrees. When we have an intersection of 90 degrees. And the intersection of anything. It could be two lines, as you guys are used to. We could have two planes do this. We can start having weird things like a triangle and a square intersect at a perpendicular. And we'll get into those. When we start looking at the different figures, you'll see these triangles and squares intersecting and forming some perpendicular places. Okay? There is a symbol that we use in writing when we are writing about perpendicular, and we use a symbol instead of the whole word. Do you remember what that symbol is? Okay, I got a lot of head shakes. The symbol for perpendicular when we're writing it is a big upside down capital T. All right, feeling better about the word perpendicular? Yep, all right. Here's the next new word. The last new word for today. The word is bisector. Have you heard that word before? No. Okay. Yeah, I figured this was going to be a new one. It's been a new one for, I think, everyone today. Let's break this up into 3 parts. We're going to break this up into bi, then sect, and or. All right. That word piece bi, what does that mean? Two. Awesome. Sect?
Cross section.
Like a section? What did you say? Section, like across, like an intersection, yeah? Yeah, I think a section, a piece of, when we're referring to a sect, would be a piece of. So like an intersection is things that run into each other and kind of divide them up into different parts. So we've got two and we've got part of, and then this suffix or usually gets used to denote someone or something that does whatever came before. Like a creator is someone who creates stuff. Yes? So this must be someone or something that makes two parts. Okay? You get the sense of what this word is going to mean? Here's the more formal definition that we are going to be using. A bisector is some sort of geometric object that intersects another and creates two congruent parts. There's no symbol for this. So I said that today we were going to do construction of perpendicular bisector. We were going to make one of these things. And using these two definitions, what do you think this thing that we're going to create today is going to do?
Something that intersects at 90 degrees.
And does what?
It makes two parts.
And makes two congruent parts. Fantastic. So we basically just smash these two definitions together for the object that we're going to make today. All right, let's go ahead and do it. We're going to title this next section of our notes, Construction Steps for a Perpendicular Bisector. These are the construction steps that are going to be the most useful to you in classwork, practice homework, quizzes and tests. When you have a direction that says construct the perpendicular bisector, of a line segment. In this case, line segment AB. Just like on, Monday was it, when I did the first construction this week? I divided my note-taking space into two, a left column and a right column. I'm going to do the same thing. You're going to see the steps on the left and the construction drawing on the right. Yes, ma'am. Yeah, go ahead. So we've got to start with a line segment. This should already be given to you. Since it's not, we've got to draw it. So take your straight edge and draw for me, please, a line segment. Label it AB. I didn't give you a choice in the matter on this one. There it is. And so we're going to construct the perpendicular bisector of that segment. Step number 1. Take a guess as to where the midpoint is, and then draw it lightly. I'm not going to draw it lightly because you need to be able to see it, but just take a guess as to where the middle is. Here. This is my guess. It might not be right, and it might not be the same as yours, but it is mine, and that makes me happy.
It's a little off. You're a little
Yeah, we're going to see how close we got. So take your best guess as to where the middle of your segment is and mark it, okay? The second step, using your compass, set the compass radius to more than half AB. So we're going to take our compass and we're going to set it to more than half of this. Now, my guess was supposed to be the guess of the middle. So I want something more than my guess. And I don't mean just a little bit more, because if I didn't guess far enough, then I'm not going to get past the middle. And I need to get past the middle. So I'm going to make sure it's way bigger than. But I don't want it to be too big, because then I'm going to run out of room on my paper. So make it somewhere smaller than the whole line segment, but bigger than your guess. Okay, that looks pretty good. That's where I'm going to set my compass radius to. Somewhere more than half. Okay. Using your compass, you're going to draw two arcs for me, please. But please make sure that they are big. And make sure that the needle of your compass is at each endpoint. So you're going to draw one arc at one endpoint, and then without moving your compass radius, you're going to draw an arc at the other endpoint. So I'm setting my needle at one endpoint, and I'm very carefully drawing a really big arc, okay? Almost a full circle, okay? I'm going to just try to make it as big as I can. Okay, I ran out of room, but that's okay. So that's about half a circle. That looks like it's going to be big enough. Now you suddenly go, oh, I know why she made me draw 10 circles in a row, because we had this coming up. Without moving my compass radius, I'm going to put my needle at the other one. And now for the second arc, I don't need to make it as big, but it's super important that I find out where it intersects that first arc that I drew. So really, I'm interested in that spot and this spot. So if you don't want to, you don't have to draw the entire arc. You can break it a little bit if you want. We're just really interested in where those intersect. In fact, we are so interested in those intersections that they're going to get labeled. So the next step is please label your arc intersections. I need labels. Help me out.
K.
J and K, I heard from two different voices today. JK. Using your straight edge, please connect the intersection points with a line. I'm trading my opaque, you can't see through it, popsicle stick straight edge for my clear pyramid. That way I can hold it and my hands up off the paper and you can still see what the drawing is. Okay. How close did you get to your guess? I didn't get very close, so you were right. I was way off. You got it right on? Very nice.
Wait, how do we do that?
Oh, I get it.
You're going to connect these two intersections.
But how do you know from where?
From this intersection to this intersection. So step 4 was to label where the arcs intersected. That was the only part that I was concerned about, where those arcs ran into each other.
Hey, I got it.
I didn't do it. Oh, I get it now.
She's so smart.
You got it right on also?
Me too.
Nice. Nice.
We're smart.
You are. Better than I am. Look at my guess. I was way off.
Can we go pee?
You got pretty spot on? Nice. Good job. This is the seventh time I've done this today, and I've only gotten one of them to come out right on it. So if yours doesn't come out right on it, that's okay. That's why it's a guess.
Yeah, mine got right on it too.
Awesome. Nicely done. You guys are...
Mine was right on.
Does that always happen? Like, I mean, is that accurate? Like,
In terms of what?
the intersection being correct?
Yeah, as long as you make those arcs with the same compass radius, this line that we're drawing is always going to be that perpendicular bisector. Always. Label this new intersection point. Can I get a label for it?
M.
M. I heard M.
I like OZ.
You like OZ? I like Aussie.
I like Sia.
So label this new intersection that you created between these two segments. This point is the midpoint. And it will always be the midpoint, provided you have used the same compass radius for each of those arcs. You started with a straight segment, and you did not allow that compass radius to move at all. Okay? We can make a couple of observations from this particular drawing. So we're going to make our observations, and then we're going to be done for the day.
Yeah.
I know, right? All right. I'm going to scroll it down or scroll it up so that way you can see the bottom of the directions and then the observations. So please use the graphic that you created so that you can look at it. You won't see it on the overhead. The first thing that you can observe is that M is the midpoint of what segment? B and A. Because that was the original segment we started with and the one that we were told to construct the perpendicular bisector of. Now you may question, is M also the midpoint of JK?
Yes.
The short answer is I don't really know. I think so. I'm pretty sure. And we could probably measure it, take our compass and set it to JM and then move it over to MK and see if they're the same. And if they are, yes. And it looks like it. But we're not really sure. This technique doesn't tell us if M is the midpoint of JK, it's going to tell us that that point is the midpoint of whatever we asked to construct the bisector of, because that's what this technique does. So for sure we can say this. We can't say the other one yet, okay? But for sure we can say this. Make sense? All right. Because M is the midpoint of segment AB, which two segments can we say for sure are congruent?
AN is congruent to MB. Yeah.
Yes. For sure we can say that. And because those two segments are congruent, what is true about their measures? They are equal. You're exactly right. Our last two observations are something that are going to come up in another section. The measure of angle JMA is equal to, JMA. Now I'm going to go up and show the diagram for a moment so that I can show you what this angle looks like. Start at the first letter J, go toward the vertex letter M, then go to the other point A. You see this space right in here? That's the angle. 90 degrees, because we said this thing was a perpendicular bisector. And it looks obtuse. It's supposed to be 90. We're going to say it's 90 because this technique creates it. Later, when I ask you, okay, go ahead and make some perpendicular bisectors, I will have reminded or taught, depending on your situation, how to use a protractor to measure the angles. And then it needs to be 90. If it's not, something happened in your construction technique that threw you off a little bit. Make sense?
Yeah.
All right. So you've looked at the measure of angle JMA. Look at the measure of angle BMK. What do you think the measure of that angle is supposed to be? Also 90. In fact, can you see all of those angles in there supposed to be 90?
Yes.
Fantastic. That's all there is to constructing a perpendicular bisector. Yeah, we're done. I'm not going to, but you're more than welcome to. Woo, I saw my shirt there. All right. Any questions on any other questions about this thing? Can I give you a little tidbit?
What?
A little tidbit? Little like Easter egg spoiler alert?
Sure.
You can use this to create a bunch of squares.
True.
Yeah. This and the other technique with congruent segments helps you make a bunch of squares.
You can make triangles too.
You could make triangles. We could make a bunch of right triangles right now. All right. Thank you very much.